Welcome to section 10.5, angles related to a circle. Our objective is to determine the measure of central angles, inscribed angles, tangent chord angles, chord angles, secant angles, secant tangent angles, and tangent angles. For homework, we're going to be working on page 474 to 478, numbers 5 to 35 odds, skip 31. So in this section, we're going to have a lot of vocab words. Our first vocab word that we're going to have is inscribed angles. An inscribed angle is an angle whose vertex is on the circle and whose sides are determined by two chords. So here we go. I think we know what an inscribed angle is already, but here's what it would look like. It's an angle whose vertex is on the circle and its sides are two chords. Next, a tangent chord angle is an angle whose vertex is on the circle and whose sides are determined by a tangent and a chord that intersects at the tangent point of contact. So here we go. We have a tangent line, and here's my chord of tangency, and we have a chord. Here's where my tangent chord angle is going to be. Now, what these two angles have in common is that their vertices are going to be lying on the circle itself. Now, here's going to be our first theorem. The measure of an inscribed angle, or a tangent chord angle, or in other words, its vertex is on the circle, is 1/2 the measure of its intersected arc. So, here's what it means. Whatever my arc is, it means that my angle is going to be 1/2. And there's my first theorem. Next, we have a chord angle. A chord angle is formed by two chords that intersect inside a circle, but not at the center. So here we go. Let me draw that out for us. Here's our circle, and here's my circle's center. If we have two chords whose intersection is not at the center, these angles that are formed in here are going to be called my chord angles. Now, here's what we have to say about my chord angles. The measure of a chord angle is 1/2 the sum of the measure of its arcs intersected by the chord angle and its vertical angle. So here we go. Let's say that we have a circle. And let's say that we have a chord angle. And we want to find out what the measure of it is. Here's the center of my circle. Let's say this arc right here is 170 degrees. And let's say that this arc right here is 22 degrees. In order to find out what this chord angle is, it's going to be 1/2 the sum of its arc and its vertical angle's arc. That's going to give me 1/2 of 192, which is going to end up giving me 96 degrees. Next, we have three new angles. A secant angle, which is an angle whose vertex is outside the circle and whose sides are determined by two secants. So in other words, it looks like this. Here's our circle. Here's two secants, lines passing through the circle. This right here is going to be my secant angle. Next, we have a secant tangent angle, whose vertex is outside of a circle and whose sides are determined by a secant and a tangent. So here we go. Here's our circle. Here's a tangent. Here's a secant. Here's our tangent secant angle. And last but not least, we have a tangent angle, which is an angle whose vertex is outside the circle and whose sides are determined by two tangents. So here we go. Here's one tangent. There's a second tangent. Here's my tangent angle. Now, here's what our theorem has to say about all three of these. The measure of a secant angle, a secant tangent angle, or a tangent angle, in other words, any angle whose vertex is outside of a circle, is 1/2 the difference of the measures of the intercepted arcs. So we'll call this arc right here x, and this arc right here y. It's going to be the same for all of these. The one closest to the angle would be our x, the one furthest away would be the y. In order to find out what the measure is of our angle, we would take 1/2 the difference of my angles, always the bigger one minus the smaller one. And now, to get us used to this, we have a bunch more examples that we're going to try. First, we're going to try and find the measure of angle A. Angle A is an angle that's outside of our circle, which means that we need to take 1/2 the difference of the arcs. 1/2 of 100 minus 20 is 1/2 of 80, which is 40. Here's another one. Find the measure of angle F. Angle F, again, is an outside angle. This is going to be a tangent secant angle. Now, first thing we have to do here is we have to find out what my other arc is, what JK is. We know 2 of my arcs, so let's add them up and subtract it from 360, which leaves me with this arc right here is going to be 200 degrees. So here we go. It's an outside angle. 1/2 the difference of my arcs, which is 1/2 of 140, which is going to be 70. Now you try one. Find the measure of angle Q. Okay, first thing we should do is find the measure of angle PAM. We know that PM is 100, so 360 minus 100 leaves us with 260 degrees left. It's an outside angle, so 1/2 the difference of the arcs. So 1/2 of 160 degrees is going to end up giving us 80 degrees. Why don't you try another one? We're going to look for the measure of angle C. Let's see what you can do. So first thing we need to do, since we know this is a diameter, we know it splits it into 180. Let's add up the angles that we know, which is 124, and subtract it from 180. That gives me 56 degrees left. It's an outside angle, so 1/2 the difference of my 2 arcs, which is going to be 1/2 of 36, which gives me 18. Our next one's slightly different. We're going to find the measure of angle Y. Y is an interior angle, which is going to be 1/2 the sum of the arcs. Now, we have a couple options here. Here's option 1, is to find the measure of this angle right here, which again, is an inside angle, 1/2 the sum of the arcs, and then subtract from 180 because we got supplementaries. So let's try that. 1/2 the sum of the 2 arcs, which is going to give me 1/2 of 76. 1/2 of 76 is going to be 38. If angle X is 38, 180 minus 38 is 142 for the measure of Y. Now we have 3 to try. Let's see what you can do. For our first one, it's an inside angle. 1/2 the sum of the arcs, which is going to be 1/2 of 115, which is going to be 57.5. For our second one, it's an outside angle, so 1/2 the difference of the arcs, which gives us 1/2 of 26, which is 13. And last but not least, we have Z, which is also an outside angle, 1/2 the difference of my arcs, which is going to end up giving me 1/2 of 106, which is 53. Here we go. We have 3 more that we're going to find. Only now we're going to be doing something slightly different. Instead of finding the measure of an angle, we're going to be finding the measure of an arc. So press pause and let's see what you can do. For our first one, we know it's an inside angle, so 1/2 the sum of the arcs is equal to the measure of the angle. Now, let's double both sides, which is going to cancel out that 1/2, which leaves me with y plus 21 equals 144. Subtract your 21 to both sides, we're left with y equals 123. For our second one, it's an outside angle. So 1/2 the difference of the arcs is going to equal my angle. Again, let's go ahead and double it. By doubling it, we cancel out that 1/2, which leaves me with 125 minus z equals 64. Now let's subtract 125 to both sides. That leaves me with negative z equals negative 61. Divide both sides by negative 1, so z is a positive 61. And last but not least, we have an angle whose vertex is on a circle, which means that my angle is equal to half the arc. Again, let's double it, which means that A is going to be equal to 130. And we're set. Alright, here's our last example, I promise. We have a multi-figure. We want to try and find out what the measure of arc AB and arc CD is. Now, again, this is a multi-figure, so we have a lot of lines that are in here that aren't going to be used at the same time. Let's see what we can do. Press pause and we'll go from there. Okay, so I bet a bunch of us got stuck. Here's what I did. First and foremost, I looked at this 24-degree angle. It's an outside angle, which means 1/2 the difference of my arcs is going to be equal to the measure of my outside angle. And then I looked at this 65-degree angle, and that's an inside angle. 1/2 the sum of my arcs is going to be equal to my inside angle. Now, let's distribute that 1/2 to both of them, so we got a system. 1/2 x minus 1/2 y equals 24, and 1/2 x plus 1/2 y equals 65. Now this is a pretty easy system. My y's are going to cancel out. Same number, difference, and front. When I add going down, I'm left with 1x, or just plain x, is going to be equal to 89. So we found out what one of our arcs is, AB. Let's go ahead and let's plug that in and let's find out what our other arc is. I'm actually going to plug it into this bottom equation. 1/2 the sum of my arcs is equal to my inside angle. Now let's double it. That leaves me with 89 plus y is going to be equal to 130. Subtract my 89 to both sides, which leaves me with y equal to 41. And we're set. So here's our answers to tonight's homework. Again, it was 5 through 35, the odds, skip 31. If you have any questions, make sure you ask. And as always, have a good one.